Thanks so much to Nico for the wonderful contextualization of this morning's event. I'm super excited to be here, see some familiar faces amongst the audience and panelists, and also some people I look forward to meeting in person someday. So I have a lot of beautiful things to share with you this morning. So without further ado, let me begin to share my screen. Great. All right. So amongst the things I'm busy with, the one that's taking all my attention might sound quite crazy, but part of the purpose that I'm here this morning to share my perhaps crazy idea with you all is because I believe we each have a crazy dream within ourselves, maybe many. And it is our purpose while on Earth to believe in the stream, embrace the stream, share the stream, and achieve the stream in order to benefit the people around us. But also, I think increasingly we are experiencing society on a global level. So the beautiful thing about connectivity, about data, about the internet, about being able to share in events like this online is that the power of an idea to spread and to be implemented is greater than ever before when we look back in human history. So let's kick off. And I know it's early, but I have a background in quantum physics, and actually some of these equations are going to be necessary as we go forward. I'm sure you recognize. I'm kidding. I'm kidding. So we're not going to be here doing any equations this morning. I will tell some beautiful things about quantum physics and about science, and later about data and technology. But we're not going to go into the quantum mechanics of the coronavirus molecule, not today anyway. Let's begin rather by looking at the really exciting way in which the space industry has been leaping ahead during the lockdown in 2020. So while 2020 has been a bit of a crazy year, there have been some huge milestones for human exploration of space in the last couple of months. So let's run through those in case we haven't kept up. So it's taken a South African, Elon Musk, to move to the US and start a couple of companies, a few companies, one of which is SpaceX. And for the very first time in the history of life on Earth, a private company run by an individual with a vision has launched NASA astronauts from Earth to the International Space Station. So these two astronauts are in fact already back safely, also returned by SpaceX's Crew Dragon capsule. And this was a huge milestone for space and showing the power of an individual. So a single individual who set up SpaceX with the endeavor of getting humans to Mars. This is a massive leap forward in terms of launching crew for the first time by a private company to the space station. That was at the end of May. During July, we've seen two launches by China and by NASA from the US, launching rovers to Mars. So the Europeans, in collaboration with the Russians, had also planned a rover which has been postponed. The United Arab Emirates has sent an orbital mission to Mars. So basically now there are 3 missions from Earth on the way to Mars, including 2 rovers. And this is an unprecedented year for sending missions to Mars. We could even say now there's traffic. If 3 missions is enough to have traffic, then the route to Mars has traffic. Humans are exploring, putting a lot of budget into exploring, and these missions are going to answer, hopefully, interesting questions like, can we find evidence of life on Mars? We've got Elon Musk here saying, this was in January, he tweeted he wants a city of 1 million people on Mars by 2050. So while this might sound like a crazy number, maybe something we even see in our lifetimes, when we see the massive steps that Elon Musk and SpaceX are taking towards achieving this goal, this really isn't so far-fetched. On the other hand, we have people like Stephen Hawking making statements like this now. Stephen Hawking, as a physicist, one of the deepest thinkers of our time, is unfortunately no longer around to ask the details behind the calculation of this number, which seems quite extreme. But we can assume from such a deep thinker that he put some thought into this number, And it leaves us a little bit unsettled as to what exactly he had in mind that would give us only 100 years left on Earth. So this is not an error in my PowerPoint. I decided we are rather going to spend our time looking at positive things. And I assume everyone has been reading even more news than they may like this year. But let me just take a few seconds to highlight some of the issues that Stephen Hawking may have had in mind when he gave us 100 years left if we don't manage to establish life on another planet. So we are in the midst of an extinction event. Extinction events can be caused by asteroids, but they can also be caused by humanity. So whether it's overfishing, whether it's the destruction of natural environments where species normally grow, whether it's pollution, largely around the disruption of natural habitats. The destruction of the natural environment is because of our industry. Our industry is because our population is exploding. In the last 100 years, having more than quadrupled. We have more people than ever. These people are even called consumers because of the rate at which we are consuming the natural environment, turning that into technology. Because of this overpopulation, coupled with destruction of the natural environment, we have climate change as another issue on the horizon. And when you have more people in one space, the increased risk of pandemics and epidemics exists. And I don't need to convince anyone of the truth of that. Moreover, we're overdue, statistically speaking, for an asteroid impact, and the sun has been witnessed to have some unusual activity later. So that's all in a nutshell, why we should be both hardworking and dedicated towards implementing some new ways of doing things on this planet. We should also feel privileged, I believe, to be alive in this time. Arguably, this era is one of the most important for humanity. The potential for change is greater than ever before. If 2020 wasn't an example of how unexpected events can arise and force us to deal with them, then I don't know what is. So let's look forward to a year beyond 2020 where we are agile at dealing with these kind of arising situations. So let's not dwell on the ways in which we may destroy ourselves on this planet. Let's acknowledge that some of these observations are indeed real, but how are we going to contribute? Because we are all here for a reason. We are all here for a purpose. And it is our life ambition to find an area where we can contribute in a positive way to a future on this planet or the next. So that was some news from 2020. We're not going to talk about the COVID-19 pandemic today. I'm sure we've had plenty of other platforms to hear about that. That was a bit of updates from the space industry in terms of what's happened in the last few months, very excitingly. But now let's take a bit of a step back, because during this section, I would like to encourage people about the power and the importance of asking big questions. So this is a question that I had the luxury of spending many years at university looking into as a student and as a researcher. Where do we come from? Now, this is a question that all children wonder about, and all adults wonder about too. And from a scientific perspective, we haven't really come to an answer. But let's first look through some pictures with which I'd like to tell a bit of a story. So, did you know that 10% of your body is as old as the universe itself? So that picture you're looking at there, that's the cosmic microwave background. Those are the very early moments after the Big Bang. That's as far back as our telescopes can see. That's an image of how the universe looked around 13.8 billion years ago. That clumpiness that you see there, that's the early hydrogen and helium that was produced after the Big Bang. And when we do astrophysics and astronomy and look at space in general, we don't see any other processes by which hydrogen is produced. So we know our bodies are more than half of water. We know that water is H2O. Therefore, 10% by mass of your body is hydrogen atoms that are as old as the universe itself. Now, if that's not an indication of the power that we wield within ourselves, as well as the oneness, the unity that all in the universe comes from this origin and shares so much history, so much matter in common, I think that's an indication of the power within us in terms of those hydrogen atoms that contain a history of the entire universe. This is a picture, and I'm seeing Poncho's in the panelists, so I hope we'll hear a bit more from her perhaps. This is a picture that as South Africans we should be proud of because it's taken by meerkats, the precursor to the square kilometer array radio telescope, currently under construction here in South Africa, as well as Australia and some other African partner states. So these are supernova remnants that you're seeing, those bubble-like structures. This is the most highly resolved picture ever taken of the center of our Milky Way galaxy. And this is just a precursor array to what will be the world's largest and most powerful radio telescope in a few years' time. So the reason I show this picture is that supernova events, when a star undergoes a massive explosion, the energy that produces the rest of the periodic table after hydrogen and helium, these kind of events are necessary to create the carbon, the nitrogen, the iron, any other elemental atoms that you find in your body. These kind of events are required to create those. So as Carl Sagan, who made science popular back a few decades ago, Cosmos was a beautiful show that they made back then. He said we are made of star stuff, astronomer and astrophysicist. That's because the matter that creates our bodies does indeed originate in the universe, the hydrogen from the Big Bang and the rest of it from events like the supernova events. So that's the center of our Milky Way galaxy. But as we get closer to home, we realize that nothing is possible, nothing interesting can happen without power. And life on Earth is powered by our 4.6 billion-year-old sun. So this is a relative newcomer in the Milky Way galaxy that hosts some of the oldest stars in the universe. In fact, some are as old in the Milky Way, older than 13 billion years. So 4.6 billion-year-old sun, a relative newcomer, but certainly nothing interesting happened in the solar system until this source of energy and mass created the planets that accreted as the debris that was swirling around the sun started to form planets. So when we look at our planet, it is unique. We must first admit that our planet Earth is unique. And one way in which it is unique is that we host liquid water on the surface in the form of oceans. So the blue planet, if we were looking back at Earth from Mars, it would be a blue colored light on the sky. And when we look at the water in the oceans, in fact, through isotope analysis, we see that the water in our oceans is in fact older than the sun. Therefore, these oceans existed before our sun. So that's another story for another day, but certainly oceans of liquid water on the surface make our planet unique. And in fact, we think that is where life may have emerged, because in a gas, my mistake, sorry. In a gas, things are very dilute, not a lot of interaction happens. In a solid, things are very rigid. And not a lot of variety of events can happen. But in a liquid, this is just the right kind of environment where we think the earliest living systems on Earth may have emerged around 4 billion years ago. So fairly soon after the formation of the planet, but also a really long time ago, we are seeing photosynthetic organisms, and we find fossils of these organisms at around 4 billion years old. So looking at Earth on the Pacific side, we see large bodies of liquid water. On our beautiful side, we see life. And this is definitely unique in the solar system. As much as we've been searching for evidence of life elsewhere, we cannot see it from space. Neither have our rovers on the surface of Mars had satisfactory evidence of life, but from Earth we see it around the equator in the north. These are the lungs of the planet, the large jungles and forests absorbing carbon dioxide, emitting oxygen, regulating temperature, regulating rainfall, those clouds that you see. All of the systems on Earth are interrelated, unified, working together towards sustaining this very unique biosphere in which we find ourselves. So the topic we were looking at was, where do we come from? And that was a very brief history of where we came from, beginning with the Big Bang. And this is, of course, the theory of how the universe originated, but it's a mainstream theory that currently is our primary way of understanding our origins. So the Big Bang produced hydrogen and helium. Supernova events produced the rest of the periodic table. Stars formed, planets accreted around these stars. On our beautiful planet, we have liquid water, and life emerged. And what do we see when we investigate this life? We see that every single living organism that we investigate contains DNA. This was a discovery made in the 1950s. And it's an important discovery with respect to understanding what life is, because Rosalind Franklin determined this double helical structure. And so far, when we look into life, we find every single living system has this structure. This is the structure that passes on information from parents to offspring. This is the structure that carries the story of life through time. So this is the information, the communication that life passes information on through time. And this is a beautiful discovery from the perspective of unity, because when we look inside our cells at our DNA, we find that all life on Earth is related. We all share the structure, we all share sequences, parts of the sequence in common, which tells us that we have a common origin here on Earth. So living systems on Earth are one beautiful interrelated system. But from the perspective of trying to understand what life is, unfortunately, that leaves us with a single data point. All life on Earth is a single data point, all containing DNA, all from Earth. But if we know we want to understand more about life, then we know we need more than one data point. And that leads me to my next topic, which is, where are we going? So from my perspective, understanding where we come from is one of the most interesting and difficult questions to answer that I've ever come across. And as a researcher, this is exactly what I enjoy. Difficult questions, profound questions, meaningful questions. So it seems that we're going to have to go further than Earth if we want to answer the question about where we come from. So the next logical step is to question, where are we going? And I'll argue that humans have always been explorers. So intriguing new information indicates that very close to where I am now, in the Tsitsikamma region, in the southern part of the coast of South Africa, like between the Eastern Cape and the Western Cape, there is very old evidence of the earliest modern humans having lived here. So we may have learned before that Homo sapiens sapiens emerged in Central Eastern Africa, somewhere near the Somalia, Ethiopia region. We may have heard other evidence of Moroccan fossils having been found. However, and as South Africans, we should be proud believers of the more recent evidence that early humans, in fact, emerged right here in South Africa. So these were the first Homo sapiens sapiens to emerge, to live in groups, to develop community, to develop philosophy, and begin exploring. Now, the distribution of humans across the surface of the planet tells us that these early humans were indeed explorers. And the first African explorers that made their way into Europe was the beginning of the dispersion of humans across the planet. But it all began here. I've heard others claim that the space industry, in fact, emerged in South Africa. How is that? That's because we have the earliest controlled use of fire outside Johannesburg in the cradle of life, sets of caves and other areas where they've excavated. So the fires here were so hot that we know they couldn't have been natural. The clay that was on the underneath of the cave has been burnt to a degree that we know is too high a temperature to have been a natural fire. Therefore, people were controlling fire in these caves. This is 1 million years ago. 1 million years ago. Now, if we need to build rockets to get to space, arguably controlling fire is the first step. So we live in a very ancient part of the planet in terms of the emergence of human life. And when we look at humans living all over the habitable part of the surface of the earth, we have to acknowledge that we have been explorers since the very beginning. Thinking about my ancestors coming by boat in 1688 from Europe back to Africa, then, since the 200,000 years before, when the first Homo sapiens were emerging in Africa. This was a one-way trip into the unknown. My ancestors were essentially refugees escaping religious persecution in France. They made their way to the Cape. Their boat was nearly wrecked off the Saldanha Bay harbor, and they were brought by a smaller boat to the Cape, where they set up what has become the agricultural region in the Western Cape. The early, largely peasant refugees from Europe set up what has become the vineyards and other agricultural endeavors there hundreds of years ago. So that's just one example of a story. And we all share stories of our ancestors having moved from one place to another and set up a new life for themselves. So I think certainly exploration is a part of who we are as humans. The largest or longest exploration we've done so far was 50 years ago, and I'm not sure whether we'd call it a celebration. It's a rather disappointing moment to realize that during the 1960s and early 70s, humans were prepared to explore further than ever before, but since then, things seem to have ground to a halt. So 1972 was the last time humans stepped on the moon, but towards another celebration, I'd like to point out that we have another opportunity for a 50th anniversary celebration. And not many people perhaps know that the first rovers were landed, or the first landers were established on Mars in the 1970s. So the Russians landed a lander that lasted for around 15 seconds in 1971. And the two Viking missions that NASA sent in 1976 were hugely successful landers, lasting well beyond their predicted lifetime. But basically, we've been able to land technology on Mars for almost 50 years. So the 50th anniversary of the first Viking landers will be in 2026. And I hope that by then we have something that we are proud of to celebrate with respect to what we've done in the 50 years since the first technological Mars landing back in 1976. So you've seen from the title that I'm going to be talking about getting to Mars, and a lot of people think this is a crazy idea. And perhaps that's why we need to do it, because we're in desperate need of some new ways of thinking, but I'll get to the motivation in a moment. If you think it's difficult to get to Mars, you would be right, because Mars is 200 million kilometers away. Even light takes 10 minutes to travel this distance between Earth and Mars. So that means if you are tagging me in a tweet while I'm on Mars, it will be 10 minutes before that notification travels 200 million kilometers between the two planets. So on the other hand, Mars is our next door neighbor. As a planet, Venus is on the one hand a bit hot for walking around on the surface at hundreds of degrees Celsius. Mars is a natural candidate. We can even see it with the naked eye in the night sky, 200 million kilometers away, an orangey color because of the rust or iron oxide that is a predominant feature of its surface. So another reason why Mars is tricky is because of the surface conditions. So we've got average temperatures of below negative 60 degrees Celsius. So for people from Durban, this sounds horrific, but for people from Siberia or for people who've been to Antarctica, these kind of temperatures are indeed present on Earth during winter in extreme environments. The atmosphere, this is something we are not at all accustomed to. The pressure of the atmosphere is less than 1% of sea level pressures on Earth, and there is very little oxygen in this atmosphere. It's mostly carbon dioxide, but regardless of the composition of the air, the pressure is too low to be able to breathe it. So certainly when you are outdoors, you're looking at wearing a pressurized helmet to enable you to breathe, and some gear for the extreme cold at negative 60 or below. The gravity is probably the fun part, at 38% of the gravity of Earth, so you won't be floating around like in a space station. Your construction will be perhaps easier to achieve than Earth, with it being, 3 times easier to lift and move things around. We don't expect the same impact on the bones and the muscles that we see in the microgravity of the space station. So all in all, a rather pleasant place. Temperatures that we can get our heads around, an atmosphere that is one challenge we will have to develop technology for, but the gravity being perhaps the fun part in terms of thinking about how holding an Olympic Games or sporting events on Mars. How high can you jump when you can jump in the 38% gravitational field? So anyway, that was a brief analysis of the surface conditions on Mars. So to recap, personally, finding evidence of life on Mars would be such an important data point towards understanding ourselves, where life on Earth may have come from, whether we are alone in the universe. We are explorers by nature, and we are really lucky to be born in this era where the space industry is thriving. Even this year, 2020, during lockdown, we have seen huge steps towards understanding more about the surface of Mars and getting crew there. But what are the practical steps? And more importantly, what are the practical steps from a South African perspective? Let's say I'm South African, I'm living near Cape Town, and wondering, how do I prepare myself? How do I become the most qualified person on Earth? How do I develop a team of people towards working to this goal, towards contributing to what will be this next giant leap for humanity, this expansion of our society beyond Earth to Mars, this massive celebration. This would really be a culmination of the 200,000 years that humans have been walking this planet. The opportunity, perhaps not to go in person, but the opportunity to know that as a society we have achieved this goal, and to be able to see through the eyes of those living there what another planet looks like in our solar system. So this is an amazing time that we live in. But what are the practical steps? And I think equally important as having a dream is the really hard work involved in trying to work towards this dream, the first steps, the practical steps towards achieving this goal. So let's do a small detour now and think back to 100 years ago, when Antarctica was the last unexplored part of Earth. It wasn't even clear if it was a continent or a set of islands. Some people had been down there, but the exploration of the continent of Antarctica just over 100 years ago was incomplete. There was a lot of unknowns about that part of the Earth. So it's difficult for us to imagine a time like that, because nowadays we've got satellite coverage, we've got Google Earth, TripAdvisor. It's difficult to find a part of Earth where no one has been before. But Antarctica was such a place more than 100 years ago. And I think the parallels between the exploration of Mars and the exploration of Antarctica 100 years ago are striking. So let's take a moment to read through this article. And I think, first of all, let's address that it's quite obvious that women are far better suited for space exploration because we're far more intelligent. Okay, that's difficult to prove from a scientific perspective. So let's say we're equally, if not more, intelligent. But really, my point is true, because if you're on a mass restricted mission, women on average weigh less, therefore we breathe less, drink less, eat less, and have the same or more brain power as a man in the same position. Therefore, it is a no-brainer that we should have gender diversity. As we were hearing in the introduction statements, we know that we need all of us on this planet to contribute to solving difficult challenges, space exploration being one of those. So it's not that men are wanted. This was 100 years ago. For space exploration, we certainly want 50-50 teams, because we need the inputs, the perspectives, the ideas from all different types of cultures, backgrounds, including gender. But besides that, I think you can see some parallels with perhaps the call for volunteers for the Mars One project going to Mars. Hazardous journey, small wages, well, in this case, no wages, because on Mars there will be no money, at least if I have anything to do with it. Bitter cold, yes. Long months of complete darkness, yes. The journey to Mars is around 6 months. Constant danger, yes. Safe return doubtful, well, this could be a tricky and dangerous business. Unknown recognition in case of success, perhaps. But when you're on Mars, I think you're not doing it for the recognition, but rather for the exploration. So I hope you agree with me in that very brief slide that there are a lot of parallels between the early exploration missions to Antarctica and what we hope to do to Mars in the near future. So what are the surface conditions in Antarctica? And that mission by Shackleton, by the way, you can watch in a YouTube documentary to see what happened. They didn't, in fact, reach the continent of Antarctica. They were coming from the northwest, from the South American side, but they were stranded at sea and had to evacuate their boat. And not a single life was lost due to the amazing leadership skills that Shackleton demonstrated. So if that was intriguing to you about what is happening on Earth in terms of exploration 100 years ago, go and check out the documentary. But let's talk a bit about why Antarctica was the last part of Earth to be explored. So the temperatures are extreme, as in the North Pole, but in fact the coldest ever temperature on Earth has been measured in Antarctica, -90 degrees Celsius. The maximum wind speeds are the strongest on Earth at 300-something kilometers per hour. Furthermore, the isolation of the place is what has made it late to be explored, and also a great comparison to how things will be on Mars. So when you go to Antarctica for the winter, there's no way out. You go there with the equipment that you bring and the team that you've gone with, and for all practical purposes, you are alone there for the winter to deal with your challenges that arise, to work as a team, and to solve challenges perhaps that you had expected and also some that you hadn't. So this is a great place to train for Mars. And I'm going to shoot through the next few pictures more as an indication from a visual perspective of what we plan to do, because I'd like to get to the last part of the talk where I talk about how this may relate back to the ideas that all of us have. So we're going to need power, solar in summer, wind turbines in winter. We're going to need water. Ice is, of course, an abundant resource. In Antarctica, so wastewater management is going to be crucial. Growing food is something we'd like to demonstrate in indoor facilities because, of course, it's too cold and in winter too dark for plants to think about surviving outside. So these kind of facilities that are already found in Antarctica will be the kind of systems we're looking at. And constant connectivity will be a requirement for whether it's for software updates, for communicating with the team counselor, for communicating back with family, for getting 3D printing designs, all sorts of reasons why we need constant connectivity. Let's think back to the first few slides. So the requirements for setting up a base in Antarctica are not that different to the series of events that led to us being here on Earth. Power is the first requirement. Water, food, and communication systems. These are the basic requirements for life wherever we set it up. Perhaps manufacturing is something we can think about, whether we're in Antarctica or in space. So I've whipped through these, but last year, realizing that as a South African, South Africa has a proud history of exploration in Antarctica, and this is a great place to train for potential settlements on the surface of Mars in the near future. So do check out the Proudly Human YouTube channel to see some more details on my visit to Antarctica last year. Also to the desert, because of course Antarctica is not the end of the story with respect to preparing for Mars. We will also look at 3D printing in the desert and all sorts of other activities like living under the ocean. But these are the practical steps that I have implemented. I quit my job last year in the corporate world to establish Proudly Human, a movement towards a future that we can be proud of, whatever planet we're on. And we plan to test ourselves, test our teams, and test our technology in environments from the Antarctic to the Sahara Desert to under the ocean, to eventually participate, along with companies like SpaceX, in the first humans living on the moon and living on Mars. So that's a huge goal. But these are the practical steps, and we all are already underway towards achieving those steps because we're building a Mars habitat installation at the Cape Town Science Centre. So once we are able to visit the Cape Town Science Centre again, all of you, if you're in Cape Town, will be free to go and check out our Mars habitat installation at the Cape Town Science Centre. So check out our YouTube channel if you'd like to see some updates on that. But let me take these next few minutes to wrap this all up. So that's been a long journey that we started off in the beginning of the universe. We ended up with thinking about the requirements for power, for water, for food, for communication, for life. We thought about big dreams like participating in human exploration beyond Earth. And we thought about practical steps towards preparing for such a grand adventure. And this is just an example to maybe inspire you that no idea is too crazy to begin practical steps towards achieving it. And in fact, I think this era that we live in, 2020 in particular, has caused a lot of uncertainty. We live in a lot of anxiety, but I think we have to look at the positive side. And in times of great uncertainty, there is a massive opportunity to implement new ways of doing things. And the opportunities that we have, because we have connectivity, because we can share ideas with a pace and with a breadth that we've never been able to do before, because we're sitting here this morning able to share ideas with groups of people that are not in the same place. This is the power of connectivity in terms of sharing ideas and working towards achieving those dreams. So Alice in Wonderland was one of my favorite books as a child. And I think we should all force ourselves to do this, to think of impossible things, even just after we wake up and spend our days working towards these dreams, because there are a lot of challenges that our society faces. And for young people growing up in this era, it's not an easy era to be born into. However, I believe there's a reason that each of us is here in this era, and that's because we have a role to play. Never before is our critical thinking so important, our curiosity. So first we need to look and say, is this the right way of doing things? Then we need to ask big questions. then we need to take practical steps to enabling us to reach answers to these questions. So at the heart of what I'm trying to say to you today, and often speaking to very young people in schools and so on, is how I'm reminded of this, is that we are all dreamers. We are all curious. We are born with a natural curiosity about the world around us, and we are born with big dreams and big questions. And it is actually our responsibility to remember these big questions, to remember these dreams, and to work towards making a better future for the next generation of young people by working very hard to achieving these dreams. So this is a picture of me back in 1997. And as my mom said, my talk hasn't even changed much because this was our project for Life on Mars. And as you can see there, so I was 14. The topics are power, air, water, food, city life. So these are the basic requirements, whatever planet we're on. Providing power, air, water, food, and a sense of community spirit. These are the challenges that Proudly Human is working towards, not only towards Mars, but also towards rolling out robust and efficient technologies for people living on Earth in terms of providing power, water, food, and communication systems, whatever planet we're on. So I don't know if you photoshopped your face onto Elon Musk's car. I don't know if I'm going to see you on Mars someday because you believe you have a role to play in terms of establishing a new community on a new planet. I don't know what each of your visions for the future are, but what I do know is that each and every single one of us has an important role to play. Each and every one of us has a curiosity. We have a dreamer within us, and it's our duty here on Earth to allow that dreamer to flourish. Thank you so much for allowing me to share my dream with you here this morning. We look forward to hearing from a super exciting lineup of other speakers. Thank you so much for your time and look forward to the rest of the morning. Thank you very much.